6.4. We are going to continue what we talked about yesterday. This time we're going to be talking about the graphs of inverse functions. So the first part of the assignment today should be fairly straightforward. I have the function y equals 2x plus 3. How do I find its inverse? Switch the x and y. And then solve for y. So we have minus 3. So I get x minus 3 equals 2y. Divide by 2. And I get y equals. Now, I'm going to write this in the separate form, so I'm going to have 1/2 x minus 3/2. I did that because since we're going to graph it, that's way easier. So you guys are going to have to remember some things about graphing. First, you're going to draw your coordinate grid. By the way, if you need a straight edge, I've got some on the table here, so you can go ahead and grab one if you need one real quick. X and Y, make sure you label your axes.
Which one do you want? I'm thinking of which one to use.
No, don't think, just do it. This is the thinking thing. Okay. This up here is the thinking thing. So let's look at our two functions that we have. First, we're going to graph y equals 2x plus 3. What kind of a shape is that going to make on my graph? A line. Where does it cross the y-axis?
3.
So we're going to have on our coordinate grid, we're going to label our axes, and we're going to go to the point 1, 2, 3. The point 0, 3 is on my line. What is the slope of my line? 2. Right here, it's 2 times x, so I go up 2 over 1, and I have the point 1, 5. Now, how many points does it take to determine a line?
2.
2. So at this point, I can use my straight edge and draw the line between the 2 points.
Where did you pick the closest?
Okay? Don't forget, if it's a line, you put arrows on both ends. Okay. Now let's graph our inverse function. Actually, I'm going to switch colors here. Let's do that one in green. So y equals 1/2 x minus 3/2. Where does this cross the y-axis?
Negative 3/2.
Negative 3/2. I'm going to say minus 1, minus 2. Negative 3/2 is halfway between those two, so I have the point 0, negative 3/2. What is the slope? 1 over 2. So I go up 1, right 2. So I go up 1, 1, 2. So that's going to be the point 2, negative 1/2. And since 2 points determine a line, I can draw the line between those.
Yeah.
They should. I want you to extend them so they cross each other. have you add one more line to this. I want you to draw the line y equals x. Should be a pretty easy one to draw. You have the point 0, 0, and it's got a slope of 1. So you go up 1, over 1, down 1, over 1.
So there's gonna be 3 lines on each
There's going to be 3 lines on this. Why do you want to see it? I'll show you in just a minute.
Because they all meet in the same spot.
Does that always happen?
Okay, let me tell you what always happens. Now, on yours, since you aren't doing it on a graph or grid right here, it may not come out exactly. But when it's lines, these 2 points are always going to cross on that line. Here's what's even more important, and this will happen on every inverse function. If I were to pick this up and fold it on that line, y equals x,
They would be exactly.
they would match exactly. It is always exactly the same distance away on both sides from that line. We say it is symmetric about the line y equals x. Okay? So now the next thing I want to remind you of, and let's start with our original line. You guys remember what a function is?
Yes.
Okay, what's a function?
Oh, time out. I got this.
I know all.
An equation.
Something that's going on.
Okay,
A line, array.
a function happens when for every x there is exactly one
One y.
Oh, what I was gonna say.
Okay, for every x there's, so if I wanted to look at this line and check to see if it was indeed a function,
The vertical line.
I need to do the vertical line test. So if I do a vertical line anywhere on there, it would only intersect that line one time. That'd be true for the original function. It would also be true for its inverse, which is the green one. Because a line is always a function. There's no way. It doesn't have any curves in it. There's no way it could not be a function. Okay, we will look at one that's not. Okay, questions on that one? Now, I hope everybody brought their calculator today because it's going to be really helpful
I saw my telecom.
in graphing this today. So let's, why do I hear chattering in the back? Okay, I have the equation, y equals x to the third. I want to find its inverse. So I switch x and y. I get x equals y to the third. So I raise both sides to the 1/3 power. I get y equals x to the 1/3. Or writing it in radical notation, either one of those would be correct. The root of x. Okay. So now let's look at the graph of that. So the first one we'll do in this red we got here. On your calculator, push the y equals button.
Yeah.
Yeah,
I was gonna ask Holly and then I just.
you never let us use calculators, so I just
I'll bring the calculator.
you know what? You don't bother to bring them. Maybe you can figure out how to do it without. I have, I believe, 2 calculators in here that actually have batteries that I can loan to people. So, no. Your phone is not going to do the graph.
Why do you have it?
Okay, I have 2.
Can I use my phone?
Okay, so you might, and I would let you use yours because, so if you're sitting don't have yours and your calculator, if you're sitting next to someone, I want you to get where you can see the screen. So I want you to look at, go to the y equals button, enter y1 equals x to the third power. And then look at the graph. Go ahead and pull your desk up there.
And then what?
Okay, then look at the graph.
You actually have to graph those on paper. It's a little.
Now,
A long graph.
I got this.
I kind of know this one. Oh. Did you get the numbers for this one?
Oh.
No, yeah, she said. She
I
said
love
it
that.
there.
If you do one
So
for
it gets my breakfast in one.
So it is, yeah, that's what I was
I can
I'll just have to check next one.
miss around that.
That's it? Wait, what did you have? Like, what was the answer?
okay. Does everybody get kind of a squiggle looking thing? Okay. Now, you can use your calculator to figure out the basic, what it looks like. We're going to plot 5 points on here. Now it goes through the point, through the origin, so I'm going to let 0, if x is 0, y is 0, 0, 0 is going to be one of our points. Okay, 1, 1. So 1, and then 1 to the third is 1, so that's 1, so let's do the negative. Negative 1, negative 1. Now, if those are the only points I picked, this could just be a line, right?
Yeah.
However, we're going to do another one. When x is 2, what's y? 2 to the third is 8.
Pick up.
2 times 2 times 2.
So we're graphing.
The original one.
Inverse. We're graphing that.
We're graphing the original one. Okay. Okay? So, why? Do I have to keep reminding you that it's inappropriate to carry on a conversation in the middle of class? Now, let's plot those points. We've got 0, 0. We've got 1, 1. We've got negative 1, negative 1. We've got 2, 8. And we've got negative 2, negative 8. So, our sketch, and you can base this off of what you're looking at on your calculator,
Okay.
should look something like that. Now, we're going to grab the inverse. We're going to do that one in green. Now, let me show you a nifty little trick here. If you have graphed the original, you don't have to go figure out the cube root of things and such. Remember what we did to find an inverse? We switched the x's and the y's. You can do that in a table just as easily as you can do it in the original equation. So I'm going to use 8, 2, 1, 1, 0, 0, negative 1, negative 1, and negative 8, negative 2. So those where the x and y are the same are going to be the same on my new function, my inverse function. So these points, 0, 0, negative 1, negative 1, and 1, 1 are all going to be the same. Now, the next ones, I'm going to go 8, 2, and negative 8, negative 2. So when I sketch this one,
Base, 90 degrees, no.
okay. Now remember the last step we did with the other one, we graphed y equals x. We're going to graph y equals x. Now, would you agree that if I fold this on that line, it's going to match up top and bottom?
Yes.
Yeah, when it's top, okay? Now, on your calculator, if you have not already done so, you already have y equals x to the third. On y2, graph x to the 1 divided by 3. And if you can't really see what's going on right in here, close to the origin, zoom in a little bit. You'll see that it kind of makes a figure 8 there in the middle.
Yeah, mine is blue.
Oh, okay.
Like they have
Okay.
that little thing, you know?
So here's what happens, is the original function, the red one, comes up here, it actually goes past y equals x. Goes to the origin, stays below y equals x, and then it crosses it again. And then the green one comes over and it actually goes past y equals x, stays below it, and then switches to the other side. Okay? So that's what your inverses are going to be doing. So on your assignment, the first 4 problems, what you're going to do, you're going to graph the original function. You're going to graph its inverse. Or you're going to find its inverse. You're going to graph its inverse. And you're going to graph y equals x. All on the same graph. Now, there's one more I want to look at. Yes, oh, is it a function? That's the next thing. So if I look at, whoops, too far. So if I look at, well, I can't find that one to see. Where did it go? Here it is. There we go. So if I look at the green one, which is my inverse, if I do the vertical line test, is it a function?
Yes.
Yes. So in this case, the last thing you would say is yes, the inverse is a function. So we need to look and see what does it look like when it's not. So there's one more type of problem that we're going to look at. Y equals x squared. What kind of a shape is that going to have? You should know this one.
Parabola.
Parabola. That one is a parabola. Its inverse would be y equals plus or minus the square root of x. So if we look at y equals x squared, we do a t-table. We'll do it on this side. So if I have x and then y equals x squared, let's do 3 points. Let's do 2, 0, and negative 2. So 2 squared is 4, 0 squared is 0, negative 2 is 4. So I've got the point 0, 0. I've got the point 2, 4. And I've got the point negative 2, 4. X, Y. Okay. Now, let's look at the inverse. We're going to do that one green this time. So first of all, let's look over here at our grid. We've got x, and I've got y equals plus or minus the square root of x. So here, if I just switch my x's and y's, I've got 4, 2, 0, 0, and 4, negative 2. Remember what the definition of a function was? And for every
Every
x,
X.
there's exactly one y. When x is 4, how many y's do I have?
One.
Two.
2. It can be 2 or negative 2. So when I graph that, it looks like this. 0. Let's see, I've got, wait, 2, 4. 1, 2, 3, 4, 2. It's like,
I did.
okay. So if I draw my line y equals x, it's symmetric right on around that, but the inverse is not a function. Okay? Okay, now on your assignment today, on page 443, 29, 31, 34, and 36 are all going to be graphed like this. You might want to use your calculator to help you figure out what the initial one, and the first one's lines, you should be able to do that without a problem. You might want to use your calculator to find out at least what your original graph looks like. Might help you decide which points to put into a t-table. I do want to see a t-table with at least, well, with the line you don't have to teach it. With a parabola, 3 points. With anything more curvy than that, you do 5. Just to make sure you get enough points to see what you're looking at. So